So we're creating a box plot. That's the same as a box and whisker for the Class B scores. The middle number we found was 7. So 7 is the middle. We're going to put the line there. And then 4 and 10 are our max and min. So then we're going to find the middle of the lower half, quartile 1, which is 6. And the middle of the upper half, quartile 3, which is 7. Again, so we don't need to draw another one in there, it's already there. And from here, it says out of Class A and Class B, which one has the higher mean score? Well, we never found the mean score of Class B, so we need to find that to be able to compare. So the mean of Class B, again, remember that's the average, add them up and divide by how many. In this case, we'd get a mean of about 6.73. So if we're comparing the mean scores, we've got Class A at 8.07 and Class B at 6.73. So which one has the higher mean score? That's Class A. Out of Class A and B, which one has a smaller interquartile range? Interquartile range is the box part. So for this one, the box part is from the 7 to the 6. So 7 minus 6 equals 1. And here, it's from 9 or 7 to 9. So 9 minus 7 is 2. So which one has the smaller? That would be Class B. Comparing 1 to 2, 1 is smaller. Out of Class A and B, which one has the higher median score? We didn't label it below, but here we know the middle is the median. So here we know the median is 8. And down here, remember the median and quartile 3 were both 7. So our median here was 7, remember that. And so we're comparing 7 to 8. Which one is higher? That would be Class A. Backside. Which graph has the highest median temperature? So if we're looking at this, each of these graphs, we've got one is skewed right, or the first graph 1 is skewed left because the tail end is towards the left. Graph 2 is skewed right because the tail end is to the right. We got graph 3 that's just kind of all over the place, and then graph 4 is also skewed right a little bit. So if we're comparing the highest median temperature, so that would be the score in the middle, then we've got the higher numbers over here in this area. So we got more higher scores on graph 1. So we could guesstimate how many are in each bar, but this graph has more high bars or more higher numbers, graph 1, than the other graphs. So that would mean the highest median temperature would be graph 1. Which graph has the highest mean temperature? So again, that's where we would add them up and divide by how many there are. And if you're going to find the mean, that's the average. Well, if you have more scores that are higher, that's going to pull your average higher. And so that's again graph 1. Which graph is normally distributed, or graphs? So there's two that look like these two. They're a little skewed right, but for the most part, they're pretty normal distribution. Each of the bars on each side, they're pretty symmetrical, and that's what you're looking for. So that you could say either graph 2 or graph 4. Which graph has had the highest temperature overall for Snow Park? Again, highest temperatures overall. So which one has scores that are going to be in the most or the highest range? So we got 13 to 18, 19 to 24. And the temperatures were the highest there in graph 1 again. Which graph is negatively skewed? So again, we could call these, we're looking at the tail ends. So when we're looking at this one, we could say that that's positively skewed or right skewed, because we look at the tail. And you could also say argument the same thing for graph 2. Again, graph 1, we're looking at the tail end. So the tail end is on the left, or it's headed towards negative numbers, so negatively skewed. So again, that is graph 1. Removing an outlier from a data set. From a data set will most likely have a large effect on which of the data set's measurements. Mark all that apply. Mean, mode, and standard deviation. So, a large effect. So what I did is I checked it. I made up a data set. So I said 1, 1, 3, 4, 5, and I made the outlier 18. So a number that was far away from the data of the other data numbers. So if you find the mean, x bar, you get about 5.3 or 5.3 repeating, 5 1/3. The standard deviation is 6.4, and the mode is 1. So now if you do the same thing, but you take out the number 18, take out the outlier, and you just use 1, 1, 3, 4, 5, the mean, well, the mode won't change, so we're going to take that one out and just not worry about it, because that's not going to have a large effect on the mode. So let's just look at the mean. The mean in this case would be 2.8, and the standard deviation is 1.79. And we're comparing which one has a larger effect. Well, the mean does have an effect on the mean. And if you were to subtract those out and compare it, the mean effect would be 2.5 about. And the standard deviation, because again, standard deviation is how much the numbers deviate from one another, how much they deviate from the mean, or vary, or are different, deviate, different, how much they differ from the mean. So if you subtract these numbers out, you're going to get 4.61, which is a larger effect on that standard deviation, because that's standard deviation again is how much the numbers are going to vary, are going to change. You're comparing them together. Okay. The bottom part of this is a review of lots of stuff. So find the area of the figure on the left. If I want the area, I need to know what these two sides are. So if I want this side here, I'm going to look at all the vertical pieces here. So 5 is the whole thing, and 2 is part of it. So this last piece has to be 3 inches. And now we look at the pieces going across. So we got 8, 6. So this bottom piece has to be a 2-incher. And then we're going to find the area. So we got to break this up into 2 rectangles. And when I do that, this bottom one here is a square. It's 2 by 2. 2 times 2 is 4. That'd be 4 inches squared. And then up here for the top one, the across piece is 8. And the piece going down is not 5. 5 keeps going. So it's the side with just 3. So it's 8 by 3. And that multiplied out is 24 inches squared. And if we want the total area, 24 and 4 inches makes 28 inches squared. Notice the shape in the next one, number 10, is the same as what we had in number 9. So this is 2 inches and this is 3. And perimeter means you add them all up. We want the total around the outside. If we walk around the outside, how far do we go? So add up all those numbers now, and we would end up with 26 inches. Shoot. Why doesn't it tell me? You know? Sorry for the long pause. I thought the video was over. Find the equation of the graph on the left for number 11. If you want the equation of a line, we have to find the slope and we have to know the y-intercept. So in this case, it's nice because there's points that hit right through that y-axis. Here's our y-axis and the y-intercept is -3. And the slope, all of these points go right through the grid, so we go down 1 over 1 the whole entire time, so -1 over 1. So we would write that out as -1 or just -x, probably better, and then -3. Y equals -x minus 3. Find the equation of this graph. It does go right through the 2, so the y-intercept is 2, and our slope, notice it goes through right there at that point on the grid, and if we come this way, it goes right through here. So we're going to find that rise and run. That slope, because it stays constant for a line, it goes up 1 over 4. And so that's y equals 1/4 x plus 2. Okay, use the histogram on the left to answer the questions. How many scores are represented in the histogram? So you have to find each of the frequencies. So from 60 to 70 in the interval, we're at the number 3. So I'm going to go through and find each of these. How many numbers there are? There's 8 for the green. There's 10. And maybe those are hard to see. So there's 3, 8, 10, and then here there's 9. So how many scores are represented? There's a total of 3 plus 8 plus 10 plus 9, which gives you 30 scores. How many scores are less than 80? So we're looking less than 80. So everything this way, both of those are included, so that's 8 plus 3, which is 11. 11 scores are less than 80. Which interval has the smallest frequency? So the smallest one here on the graph is 3, and that's from 60. And if you're talking about an interval, it's probably to 69, 60 to 69, instead of 70, because that would be included in the next bar. So here